Hello and have a good day to my lecturer, Dr. Tiang, and fellow friends. Hopefully, you all are stay healthy, stay safe, and stay cool. Okay, today I'm Shahril Haniff bin Ibrahim from RK23, Electrical System Engineering, want to present about the project of this subject, which is electrical power technology. The project is analysis of three-phase transformer in Y-connected generator. So, let's go. Okay, for introduction. First, three-phase system are widely used in generation, transmission, and distribution load of electric power. Second, it is a pair of generator and load, which is the generator will produce three sinusoidal voltage of equal magnitude and frequency but different in phase by 120 from each other. Third, three-phase system have two sequence, which is positive sequence is ABC and negative sequence ACB. 4. Three-phase system have two types of connection for generator, which is Y-connected generator and delta-connected generator. Same goes to the load connection. For Y-connected three-phase circuit, it has two types of connection, which is 3-wire and 4-wire connection. Okay, then we go to the objective. We have 4 objectives. First, we want to analyze the three-phase Y-connected generator. Second, to evaluate the parameters of electrical system. Third, to determine active power imbalance three-phase circuit using 2 wattmeter method of power measurement. And lastly, to determine reactive power and apparent power using measurement of circuit voltage and current. So, we go to the methodology. In methodology, we have flowchart. Flowchart can show the step by step, the progress. Firstly, project assigned by lecturer. Next, we draw a Y circuit. Third, find all related parameter. Fourth, we create circuit in the simulation software. Then we run the simulation, and the last, we complete the report and submit. This show the step by step. First, we get one assignment, which is project assigned by lecturer. Then the project is about three-phase system in Y-connected generator. Next, we draw Y circuit in schematic diagram. Then we find all related parameter. After that, we create a circuit in system software. After we create, we run the simulation based on the circuit that we create. And lastly, we complete the report and submit. This shows the basic circuit in the system simulation. This is the basic circuit. And then this is the schematic diagram. We use the eDraw software to draw the schematic diagram. For the frequency we get is 50 Hz. So we also know the step to get load and loss, which is we get from metric number. The value of A is 81, B is 9, C is 8, and D is 13. So for result and discussion, for calculation transmission, loss and load is firstly we calculate value for inductive reactance at transmission loss. The formula is SL is equal to the 2 pi SL. We know the SL from metric number is 13 and the frequency is 50. So we can get the L. L is inductive. So the L is 0.0414 unit Henry. Second, we calculate value for inductive reactance at load. We use the same formula, which is SL is equal to the 2 pi SL. The SL is 9 and the same frequency, which is 50 Hz. So we can get the value of L is equal to the 0.0286 unit Henry. Next, for transmission loss in ohm, we call Z line is equal to the 8 plus 13 J ohm. Then load in ohm, we call Z load is equal to the 81 plus 9 J ohm. So for the total impedance is equal is Z line plus Z load. The total impedance we call ZT. So the ZT is equal to the 8 plus 13J, which is the value of Z line, plus 81 plus 9J, which is value for Z load. So the total impedance is 89 plus 22 J ohm. Or in the rectangular form is equal 91.679 degree of 13.885 ohm. So the generator voltage, as we know, the E line was given, which is 275 kilovolt. It is a positive sequence ABC. So we can calculate the value for V phase. V phase is equal E line divided by 3 degree of 30. Okay, for the VAN is equal 275 K degree of 0 divided by 3 degree of 30 is equal 158.77 kilo degree of negative 30 volt. For VBN is equal 275 kilo degree of negative 120 divided by 3 degree of 30 is equal 158.77 kilo degree of negative 150 volt. For VCN is equal 275 kilo degree of 120 divided by 3 degree of 30 is equal 158.77 kilo degree of 19 volt. Therefore, VAN is equal the capital letter VAN and VBN is equal to the capital letter VBN. Just one VCN is equal to the capital letter VCN. Then we go for the current. For I line is equal, I phase is equal to the I capital A and small capital A is equal to the IAN and equal the capital letter IAN. For IAN is equal to the VAN divided by total impedance or ZT is equal to the 158.77 kilo degree of negative 30 divided by 91.679 degree of 13.885. Then the answer is 1731.80 degree of negative 43.885 ampere. For IBN is equal VAN divided by total impedance or ZT is equal 158.77 kilo degree of negative 150 divided by 91.679 degree of 13.885, and the answer is 1731.80 degree of negative 163.885 ampere. For ICN is equal VAN divided by total impedance is equal 158.77 kilo degree of 19 divided by 91.679 degree of 13.885, and the answer is 1731.80 degree of 76.115 ampere. Okay, then for load voltage is VAN is not equal with the small capital letter VAN because there is no transmission loss. The small capital VAN, the small capital letter VBN, the small capital VCN is equal to the V load phase. VAN is equal to the IAN multiple with Z load. VAN is equal to the 1731.80 degree of negative 43.885 times with 81.9 J. VAN is equal 141.14 kilo degree of negative 37.54 volt. For VBN is equal IBN times with Z load. For VBN is equal 1731.80 degree of negative 163.885 multiple with 81.9 J. 81 plus 9 J. Sorry. So the VBN is equal 141.14 kilo degree of negative 157.54 volt. For VCN is equal ICN multiple with Z load. VCN is equal 1731.80 degree of 76.115 times with 81 plus 9J. So the equal VCN is equal 141.14 K degree of 0.46 volt. For voltage drop is equal V supply minus V load divided by V load times with 100%. So voltage drop is equal 158.77 kilo minus 141.14 kilo divided by 158.77 kilo times with 100%. So it is equal 11.50%. 11.40%. For active power at load is equal I phase times with V phase times with cos voltage minus current. So it is equal 3 times 1731.80 times with 141.14 kilo cos negative 37.54 plus 43.885. So that's equal 728.794 kilowatt. Okay, so this is the graph from the simulation software that we get. And firstly, we get the VAN. The graph shows the value of VAN is 141.14 kilovolt. And then value of VBN from the graph is 141.14 kilovolt. And the last one for VCN from the graph we get is 141.14 kilovolt. Based on the result, we can see the voltage value of VAN, VBN and VCN are same, which is 141.14 kilovolt. So we can know the voltage value from manual calculation are same with PC software calculation. For current, we get for IAN from the graph is 1731.80 ampere. For IBN 1731.80 ampere. And the last ICN is equal 1731.80 ampere. Based on the result, we can see the current value of IAN, IBN and ICN are same, which is 1731.80 ampere. So we can now the current value for manual calculation are same with PC software calculation. For real power, we have two, real power 1 and real power 2. From the graph for real power 1, we get 243 megawatt. And for real power P2, we get 137 megawatt. For the wattmeter method, we refer ESA underscore V3. The power factor is 0.9, lagging. So cos negative 1, 0.9 is 25.8419. Power measured by first wattmeter, which is W1 is equal IL multiple with with VL cos 30 minus 25.8419. So the equal is 243 megawatt. Power measured by second wattmeter, which is W2, is with the same formula, which is IL multiple with VL cos 30 plus 25.8419. We get 137 megawatt. Therefore, to get the total power delivered to the load is equal PT is equal P1 plus P2, which is 243 megawatt plus 137 megawatt is equal 380 megawatt. Based on the result, we can see the value of real power P1 and P2 are same, which are 243 megawatt and 137 megawatt. So we can know the current value from manual calculation are same with using software calculation. Okay, then lastly, conclusion. We have 5 conclusions. First, we can know the value line voltage are at a phase difference of 120 degrees from each other. For example, VAN is equal 120, VBN is equal negative 120, and VCN negative 240. Second, the root mean square of a voltage or current is given by VRMS is equal VP divided by Z3. We can analyze the three-phase Y-connected generator. We can determine active power imbalance three-phase circuit into wattmeter method of power measurement. The objective from this experiment were successfully achieved. So for the questionnaire session, I want to ask to you all one question only. Is that same formula for YY generator equation and data generator equation? So that's all presentation from me. Thank you very much for watching. Bye.